parabolic spandrel, that it is a thin sheet cut like this. Y is equal to kx square. Coordinates they are A and B. So obviously A point and B point, they are going to satisfy this equation. We are asked what is the center of mass of this spandrel or this sheet, thin sheet which has been cut like this and placed like this. So over here we see that there is no axial symmetry, and we see that its mass is distributed over area. So obviously we are going to use xcm is equal to integral x dA over integral dA, and similarly ycm also we can find out. To find the xcm, what we do is, at a distance x, we take a very thin strip of thickness dx, and obviously because y is equal to kx square, so this is going to be y. If you open it, this strip, so its height is or width is going to y and thickness is going to be dx. First let's find the area, total area of this spandrel, which is integral of dA. So integral of dA, if we say, that is area. What is differential element of this area is length into breadth, because this is a rectangle only, y into dx. So y into dx, what is y? Y is equal to kx square. So in terms of x, the limit of x goes from 0 to a, from 0 to, this is a, 0 to a it goes dx. Area comes out to be, this is k comes out, x square dx, that is raise the power by 1, x cube, and raised power comes in denominator 3, so it goes from 0 to a, it is ka cube by 3, we put the value of k, because y is equal to kx square, so we put the value, this point is going to satisfy this, so b is equal to k into a square, this implies k is equal to b upon a square, we have put the value over here, so this comes out to k into this thing, k comes out to b upon a square, so we put the value of k is equal to b upon a square into this, so it comes out to be ab by 3. So this is the total area of this spandrel. Now let's use this formula, that is xcm is going to be integral x dA over integral dA. dA integral dA we have found it, that is this is ab by 3. X into dA. dA is what? Differential element of this area. What is that? That is y into dx. We put the value and replace y by kx square, because y is equal to kx square. So we have put the y is equal to kx square where k is constant. So we put the value over here. So this comes out with k integral. So integral, this is going to be x cube dx, that is going to be x 4 by 4, limits 0 to a, and when you put in the value, this comes out to be xcm, comes out to be 3a by 4. Now we find the ycm also, because we have to find the center of mass, so this is going to have xcm also and ycm. Because there is no symmetrical axis, as a result we need to find xcm as well as ycm also. So to find the ycm, what we do is, in the same spandrel at a distance y, we take a very small strip of thickness dy. The thing to understand is that this curve is parabolic curve, is y is equal to kx square. So this point is going to be satisfied by the equation y is equal to kx square. So from here to here, if this is x, the total distance from here to here is a. So this is going to be, the width of this small strip is going to be a minus x. Rest is, we use the same principle. Ycm is equal to integral of y dA over integral dA. dA integral, we know that is total area, is we have found out, that is ab by 3. Over here now it's a numerator, it is y into dA. dA is what? dA is, that is a minus x, length into breadth of rectangle, that is a minus x into dy. We put it over here. So this comes out to y a minus x. Now we know that is y is equal to kx square. So it means x is equal to y by k, where k is constant obviously. We can find the value by putting it, that is b by a square, that is constant only. So y by k dy. So when we open this, so we can make it into two integrals. So y a dy, that makes the first one, and y root y by k dy, that makes the second one, divided by, then obviously this is a by 3. So this makes, then obviously, that is not the integral, but y a dy, this will make, a will come out, and this is y dy, this will make y square by 2. So a y square by 2, and over here if you see, root k is a constant, this will come out, and this is y into root y. So this is y into y raised to a half, so this is y raised to a 1 plus half, that is y raised to a 3 by 2. So what we do is, y raised to a 3 by 2, when we integrate it, raise the power by 1, and the raised power comes in the denominator, and divide by, whole divided by ab by 3. So y bar comes out to be 3b by 10. So the center of mass is somewhere over here. So xcm is 3a by 4. So this is 3a by 4, if we say this point P is center of mass, so x coordinate of this is 3a by 4 and y coordinate comes out to be 3b by 10. 3b by 10. So this is center of mass of this parabolic spandrel.